Hi, I'm Karthik Rannan. I'm the president of the Wall Street Club of BITS Pilani Hyderabad campus. Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives while they try to navigate the world of finance. I am happy that we will be able to close this workshop successfully on a very good note.
Hi, I am Raghunendra Singh and I am the Technical Director of the Wall Street Club at BITS Pilani Hyderabad campus. It was a great amazing conducting this workshop with XLR. The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets, which was very helpful for the people who are interested in the field of finance, business or analytics in general. Thank you.
I attended a workshop conducted by CSA and ACM in collaboration with XLR. So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
The journey was great. Initially, I thought that I was not proficient enough in Excel, but later I came to know there was no prerequisites for it, and then I applied for it, and it was a great course, and it started from basics and took me to a great extent.
Good evening, myself Kavya Ganatra. I am from Computer Science Association. I was the POC for this ML workshop conducted by CSA and ACM in collaboration with XLR. The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it. Thank you.
my name is Tasneem. I'm the senior manager at 98 Percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time we would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
Hi everyone, my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th Percentile. So today we were here for this IT bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them all the best and it was a very great experience over here.
Hi, this is Patan, Technology Consulting Manager from 98th Percentile. We visited XLR for the campus placement drive and it went very well today. Ms. Ambika, Ms. Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. it was a great experience altogether.
Thank you.
Thank you so much.
From entering into this cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 90th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot, and I experienced a lot of things today. So I'm really hope to be I placed in that company. I'm confident about that. Thank you.
Hello everyone, good afternoon. Hope you guys are doing fine. So guys, I request everyone to join in fast, who are not joined in. So we're going to start the session in couple of minutes, 2 minutes exactly. So my dear professors, colleagues, members, who are not joined in, please join in fast so we can start the session. Guys, the agenda for today will be like we are going to understand the entire training methodology, how the ChatGPT or the large language model gets trained. So today's session is totally dedicated for the training, right? So we'll try to understand each and every part of the training, like how the entire training comes into the picture, what are the phases, what are the different techniques which are used, right? So we'll try to understand the entire architecture, how it is getting trained, what are the training methodologies, and so on. So today's topic gonna be very interesting, guys. And then from tomorrow onwards, we'll start building the applications. So once we are already completely aware of these applications, so we can start building the application. We'll try to build some use cases. All right, guys. So just 2 minutes and we'll start the session. So I request once again everyone to join in fast, whosoever not joined in. So I don't want anyone to miss the session from the beginning. So guys, we'll start exactly in 2 minutes. All right. Hello everyone. Good afternoon once again. So can you guys from the participant side, can you quickly guys confirm that you're able to see my screen and you're able to hear me properly? So we can start without further delay. All right, Dr. Anupama Sangavan, thank you, ma'am, sir. Thanks for the confirmation, guys. Couple of more confirmation and we can start. I guess everyone settled down. Just give me the confirmation, though we can start the day. Okay, Aisha ma'am, thank you. Pinad Naidu, sir, thank you. All right, guys. So, yeah, good afternoon once again, sir. Naidu, sir, thank you. All right, guys. So let's get started. Okay, Pranali, I'm able to. Okay, thank you. Thanks, guys. Thanks for your confirmation. So let's get started today. Today's topic going to be okay. Deepak, thank you. So, guys, today's topic going to be very interesting because we'll try to understand the entire internal architecture around this chat GPT or this kind of a large language model. So how these large language model are getting trained and what kind of a things happens inside it, right? So we're going to look in the entire internal architecture today. We try to understand very some important concept out here like what is prompt engineering, what is supervised fine tuning, what is proximal policy optimization, what do you mean by reinforcement learning with the human feedback, how this three-step model works upon, so how this entire chat GPT get trained. So, and then we'll try to understand some of the fine-tuning techniques, how to evaluate your large language model. And in the end, we'll try to understand that if you want to make this kind of application working or you want to create an application using it, so what kind of a things you will be required and what will be the some kind of a challenges you can face during the training and all. So, and what are the things that will be taken care accordingly in order to fine tune this kind of algorithm. So guys, we were able to successfully understand the entire architecture, the how the text generation has been done in the transformer, prior to transformer, later to transformer, what is attention, how the attention works upon, what kind of attention weights it is creating, what is positional encoding. So I guess everyone is super comfortable with the entire architecture of the transformer, and transformers are the base, guys. They are the base to understand the large language model, just like the generative adversarial networks, GANs. So GANs are responsible to create a large vision model. So which in terms are creating the images, videos, audios, right? Or whatever kind of emotions you are able to see, this kind of entire thing is getting generated. So guys, today let's get started with the high level overview that how this chat GPT actually gets trained and what are the components, what is the entire project life cycle of this generative AI. And then we'll try to dig down or we try to deep dive into one concept each, starting from one element we'll try to pick up here from this diagram and try to understand in total, okay? So let's try to understand how to begin and what is the entire architecture look like and what is the project life cycle, all right? Let's imagine this way that you want to build one kind of a application. That application is using the generative AI, right? This is what you are aiming to perform. And now let's imagine that you are trying to build a chatbot, all right? You are building a chatbot which will work as your personal advisor, okay? As a personal advisor on the stock market investment options, okay? Personal advisor, I will say. So personal advisor who will help you or he will help you to find out the stock avenues, which are the better avenues here for the investment purpose, And out of that, how you can implement this, what will be the suggestions you will be getting. And once you will able to communicate with this one, so you'll be able to good. Yeah, Dharam sir, good afternoon. Long time no see. So hope you are enjoying Dharam sir, this kind of a lectures for the generative AI. So guys, let's imagine that now you are building a chatbot, which is completely a financial chatbot. All right. So this chatbot is totally dedicated in the domain of the, let's imagine it is in the field of the financial domain, and it is totally dedicated itself for the stock market, and it will be able to scan the entire stock market based on your preferences, and you will be able to interact with your bot You'll be able to understand which are the top 5 stocks and how the entire things are working, what is the market trend, how the trends are going on, what is market today, what is going to be future. And accordingly, it will help you to become your personal financial advisor in terms of the investment avenue, right? Financial advisor. So that kind of a bot you want to build upon. Let's imagine this way. All right. So where to start? Our use case we have defined. So I want to build a financial bot. All right. Financial bot I want to build. And now in order to build the financial bot, what I have to do? What is the step one? So step one is, guys, you have a two option now. All right. One is that you can use one pre-trained model. So first start with the selection of the model. Okay. Select the model actually. The first thing will selecting the model. Now you have an option that you can use a pre-trained model. Okay. Pre-trained model. So this pre-trained model are available just like the ChatGPT model. ChatGPT. Guys, this ChatGPT has two versions. One is GPT 3.5 and one is GPT 4. These are the two models available. GPT 4 Turbo actually. Turbo, this model is available. And this is from the company OpenAI, right? This is what we can understand. OpenAI company has developed these models. So these are the large language model which are available, and they have a two variants. One is 3.5 and one is 4 model, right? So 3.5 is, I guess it is completely free for the certain accesses, and then 4 is a paid version, turbo version also. So what we have to do is, in order to build this financial bot, so this bot will be able to help us to scan the entire stock market situation, and it is able to give you an entire feedback. You can interact with it just like the Alexa. Just call this as a Felexa. Felexa, because she is a financial domain expert. So Felexa. So Felexa is a financial expert, and we have to create this financial expert so she can scan the Indian stock market. She can help you with the different financial advice, investment avenues. Let it be a stock, let it be a debt, let it be future derivatives, or let it be any kind of a mutual fund new offering happening. So it will be able to give you update, and it will be able to suggest you the top 5 funds, top 5 stock markets, top 5 future derivatives, and it will help you to perform an intraday training as well. You can interact with this bot, it will be able to help you. So you are building this bot, okay? This is what you are trying to understand here. So for first thing, when you want to build this kind of a bot, is first thing will be you have to build a model. First, you have to train the model. You have to choose that which model you will be using, whether you want to use the existing pre-trained model or you want to pre-train your own model. Okay. The second option will be you want to pre-train your own model. So you can choose one base model. So option 2 will be you can pre-train your model. Pre-train. Okay. Pre-train your model means you will be using some kind of a GPT model only, generative transformer, right? So pre-trained transformers, but these transformers you will be trying to customize it right from the beginning. You can customize it with your own data, and you can start from the scratch. You can start from the scratch entirely from the stage 0, and you can keep on building. Okay, this is what the two options. Let's imagine if you go for the pre-trained model, so which is called as supervised, which is called as a transfer learning approach, right? Transfer learning approach. Transfer learning. So where the model is already built by someone, it has certain capabilities. Now what we have to do is we have to download that model. You can download that model, and you can use the kind of APIs or interfaces. APIs could be like Hugging Face. APIs could be kind of LangChain. So anyhow, guys, tomorrow we'll try to understand this entire LangChain. Okay, we'll try to focus on this framework which is called as LangChain, which is a framework used to customize or make your large language model to interact with your own data. Okay, to interact with your own data, you can customize your entire application. It has a certain capabilities and functionalities. Using that functionalities and the access to the vector databases, access to the vector databases. Vector database, I will explain you. This is nothing but your own data is stored in kind of a databases. That database can be exposed to your large language model using this kind of a LangChain application. LangChain framework will try to focus what is the LangChain, what are the capabilities, and we'll try to build one application using LangChain tomorrow onwards, right? So we'll try to understand completely this LangChain framework. So let's imagine what happens is either one, you have a two option for the modeling purpose. You can go for the pre-trained model, just like the ChatGPT 3.5 or 4 model. You have a model like a BARD. You have other models as well, like BARD model is there, or you can have a PLM model or some other model, Falcon, whatever models are there. So you can use that model, you can download that model, you can use any API like Hugging Face or LangChain, some kind of a framework, you can or expose that model to your own data. Let me rub these things actually. Let's make it very, very nice actually. So here we started, we have to build a financial bot, right? Financial bot, and this financial bot will be able to give you a question and answers related to entire your stock market, and will work as your personal virtual assistant, financial virtual assistant, right? FVA. So call this as a Felexa. So Felexa, we're going to build a Felexa model. Now, first step, what we'll be doing at building this architecture, right? So you have to choose a model. Now, one is that option is that you can go for the pre-trained model, pre-trained one, or second option that you have is you try to pre-train your model from the scratch, right? Start from the zero. Start from the zero and your own model you can train here. Own model you can train here. Now, this is what the option you have to do. If you want to go for any pre-trained model, you can refer to just application just like I spoke upon. So you can go for the ChatGPT kind of application, which is actually GPT 3.5 or 4 model or turbo model, and which is created by the OpenAI. This kind of a company, and they are having this model. So you can download this model, you can expose this model using the LangChain, or some other frameworks are there which are very popular. So if you want to use the open source model, this is the LLMA index is there. LLAM, okay, LLAM. So this LLMA Llama index is there, popularly called as Llama. LLMA index is there, LangChain is there, or you can use the Hugging Face platform. Hugging Face is, guys, Hugging Face models is actually a platform which is giving you entire model hub. So where all the pre-trained models are available, you can use that application to deploy your model, where you can deploy your model, or you can use that interface to train your own models. Okay, train the pre-trained models as well. So these are both the options available. So this is what you have to choose. Now between choosing this existing pre-trained model and choosing your own model. So I'll come to this part, like what we should do and how should we train around it. So this is part is clear, I guess, for everyone. So selecting the model. This is what you have to do. Now, if you want to create a model, which is domain specific, actually, at that time you have to pre-train the model. If you don't want to create a domain specific, you want to just utilize for your own data, a small amount of a task you have to add, then you can go for an existing one. That's how the logic will be. All right. So then once we're able to understand this one, okay. So that what will be the steps? This is step one. So step two will be, guys, then what we have to do is you have to perform something called as prompt engineering now. So this is where the actual training will start actually for your model. So once you have chosen a model, then your training will start. Now what we have to do is, so for the training purpose, what happens is there are the 3 steps which happens here. So first step will be supervised fine tuning. Supervised fine tuning will be happening. Then what will happen is there will be something called as supervised fine tuning will happen, and then something called as then the option which will be called here is a kind of a human feedback reinforcement learning. Okay, human feedback reinforcement learning will happen. First, the supervised fine tuning will happen, and then, guys, there will be third thing which will be called as proximal policy optimization, PPO. This is what is going to happen. There are the 3 steps. We'll come to know what are these steps, what is supervised fine tuning, what are the fine tuning operations are available, what will do. So, but now when I'm started understanding and adopting the model and trying to align it and trying to tune that model, try to train that model, what I am trying to understand how the entire ChatGPT, this model is getting trained is that first we are taking the base model here. So that base model could be a transformer model here, correct? Transformer model. Then transformer model is getting trained on the huge chunk of a data. Huge chunk of a data could be entire encyclopedia, or could be the entire data which is available on the internet, open internet, or could be a very, very huge whatever books are available. Let's imagine in your entire library, that kind of entire books are fed to this kind of a transformer model. Right? So this is kind of a ChatGPT model we're trying to develop here. So our model is Felix, obviously it's a financial domain expert. So what happens is there are 3 steps happening here. One is prompt engineering happening. We'll come to know what is prompt engineering. This is the first topic we'll try to start here. So what is the prompt engineering? Then something called as fine tuning will be happening, guys. So we'll try to understand what is the fine tuning, and then alignment with the human feedback. Alignment with the human feedback means what? So means you have seen that whatever the large language model are there, whatever the ChatGPT, Bard or Falcon, or let it be a Mistral, whichever the latest model now, Microsoft 5 model. All these models are DALL-E model, other models. So DALL-E actually is a different model, it's not a language model. It is generating the images and videos, other midway and journey guys. So whenever we are talking about a large language model, what is happening is they are generating the text which is just like the human being. You are able to talk like the human being. So how they are able to perform that task? So that task is called as alignment with the human feedback. Like what we going to understand is how whenever it is trying to generate a text which is just like the human language, at that time there will be a humanoid touch to them. A human person, a human or a person will be there who will try to judge this entire generation of the text, and he will try to make a kind of a reinforcement learning here. Reinforcement learning. Okay, we'll understand what is this human feedback reinforcement learning. Human feedback reinforcement learning. Human will be giving a rewards to this whatever generation output is generated here. So that you output will be given a feedback by the humans. Human will try to evaluate that feedback or output, and then accordingly it will try to hit it, or it will try to give a penalty, or it will try to give a reward. So that is what the reinforcement learning is all about. And then proximal policy optimization, guys, this is a one more last method which will be used, which could be optional sometimes. So what is happening is here, it is one of the algorithm actually. It is one of the algorithm for the reinforcement learning. Okay, proximal policy optimization. What happens is once we are able to take this data, we are able to perform entire prompt engineering. We'll come to know what is prompt engineering. Prompt engineering means simply we are trying to write some query, right? In the form of a text, and that text has to be understood. So that is called as prompt now. Okay, we'll come to that. We'll start with the prompt engineering. So let's try to understand. Once I am able to select the model, let it be a pre-trained model, or I am trying to take the base model and trying to train on a huge chunk of a data. At that time, what is happening? I have to do something called as prompt engineering. Once I do a prompt engineering, I have to perform a supervised fine tuning. So fine tuning could be parametric fine tuning, could be a LoRa kind of a low ranking adoption kind of a thing, or QLoRa or Fedora. So there are different models we try to understand. And then once we are able to do this kind of a fine tuning, parameter efficient fine tuning, then guys, we have to do a alignment with the human feedback. Means whatever text it is generating, whether it is trying to generate the text just like the human being or not. Simply, I will say, we'll go into detail, we'll try to understand. And then once I am able to understand whether it is able to generate the text just like the human being, then I have to optimize that model by using a reward model actually. By using one kind of a reward model, I'll be optimizing that entire inferences. And at that time, I'll try to train that with this kind of algorithm, which is called as proximal policy optimization. All right. So this will be the step 2. And then step 3, guys, what we have to do is we have to evaluate our model. So try to understand how to evaluate the model basis of what scores we have. A Belly score, when a glue score is there, some kind of scores will be there, guys. So we'll try to understand how to perform this kind of a evaluation of the large language model. So some popular methods will be there. We can do a benchmarking as well. And once we are able to perform this kind of evaluation, guys, then we have to deploy the model. Now, while deploying the model, what are the steps which are required, or something called as now try to understand. When we are generating the application out here, right? Once we are able to deploy the model, you are trying to generate application. Our application is a bot, right? Which will be able to perform an entire kind of a financial advisor stuff. So at that time, what I have to do is that financial bot or whatever the pre-trained model you are using, that model could have a limited capability, right? So if you are using a ChatGPT application as your base model, which is could be a 3.5 version or 4 version, that will be trained up to certain year cutoff. There will be some cutoff date. Some cutoff date will be there for this. Let's imagine it has been trained till September 22. After that, that model is available. That means whatever the data will be fed to this model, it will be available till September 22, right? So let me write it here. September 22. This was the last time when this ChatGPT was get trained, right? After that, it was cut off from the training and it is made available now. So what will happen is whatever the event occurred, whatever the events which are occurred after September 22, that kind of a data is not available for your model, right? So that kind of a data is not available. So in order to perform that kind of a, to bridge that kind of a gap, to bridge that kind of a gap, right, for your data, which is not able to understand the current situation, you have to augment your model. You have to augment your model. Augment your model means this is a popular approach which is called as RAG. Okay, retrieval augment generation. So which is nothing but we trying to expose your model to a data using the vector DBs. And what is this vector DB? We'll try to talk about. So vector databases will be there. By using vector databases, you're trying to expose your model to the specific data set. And then, guys, once you are able to do this kind of a RAG kind of a application, RAG modeling, then you can build your powerful application. Then your bot will be ready. All right, this is what the overall overview look like. So let's try to understand in the detail one term each, like what is this RAG, what is this called as SFT? What is prompt engineering? What is this supervised fine tuning or parametric fine tuning or some other methods are available? And then how we'll understand this reinforcement learning using the human feedback, and then we'll try to understand the PPO, proximal polynomial optimization. Then we'll try to understand the evaluation methods. We'll try to understand what is the RAG method. How can you include this your own databases where if you are using the pre-trained model, that data will not be available, right? Current data, how you can insert that current data, how can you bridge that gap? And once you are able to bridge that gap, you are exposing that your model, which is completely done this fine tuning and everything, it is able to generate the human like feedback. And then what will happen, how you will be able to build the application. This is what we'll try to understand. And once you understand, that means you become an architect of this application, large language model, right? And once you are know the architecture, once you are know the steps, when you are know how to evaluate a model, how to optimize your model, what kind of optimization techniques are available, then tomorrow onwards we can start building a application, right? Like using the framework LangChain, LLMA. I'll try to take one example from LangChain. I'll try to take one example from Llama Index. So let's see how the time permits and what kind of a code will be available. If I am trying to get some kind of a charges, so I will try to avoid them. So because this some pre-trained models will incur me a lot of cost. So let's see how it happens. But I'll try to make some use cases, guys. Live use cases. We'll try to build a live large language model. All right. So I guess now everyone is understood what is the project life cycle, and we'll try to understand now. We'll try to go one step further. First, I will give you overall overview. What is this supervised fine tuning? Then we'll go, guys, one by one, step by step inside that. What is the prompt and all, right? What are the sampling method? What is the prompt? And how can you perform this entire language pre-training? What are the three options available here? And then what are the challenges? And obviously, quantization is the one more important techniques. And I'll try to tell you the actual cost, how that cost is getting occurred, what kind of a technologies are used in this kind of a like parallel GPUs or this kind of a fully shared data parallel. So then we'll try to understand how to optimize your cost, and then we'll go into something called as fine tuning. All right. So one by one, we'll try to take these topics here. We'll try to understand. Then last topic I'll cover is this human feedback with reinforcement learning. There also I will try to cover this kind of a policies and this proximal policy. And then we'll try to inculcate something called as constitutional AI. Like if your AI is performing some kind of a hallucination, or it is going rogue, it is not able to perform correctly, or it is trying to perform something illegal. At that time, how we can take care of that, which is called as guardrails or some concept is there. So we'll try to understand the concept, guys, and then we'll try to understand the last thing. So which is the optimization techniques, and then we try to understand in the last the RAG, retrieval augment generation, and then you guys will be ready, right? So build the model, right? So let's go back now. I given you enough overview. So let's try to understand one by one. So guys, what happens is, especially when I'm trying to talk about the ChatGPT get trained in the 3 steps, guys. 3 steps, okay? So what are these 3 steps? First step is called as SFT. SFT. Then second step is called as human mimicking the human preferences, or you can see this as a reinforcement learning with the human feedback, RLHF concept. And the third concept will be PPO, proximal policy optimization. All right. So these are the 3 steps which are happening. So let me tell you what is happening in the supervised fine tuning. Supervised fine tuning means something what is happening is you are taking one kind of a base model. So base model means it could be a pre-trained language model, just like the transformer, or you can say the model which will be could be a BERT model. Okay, BERT model is bidirectional encoder representation for the transformer, BERT, BERT. So it is a kind of a transformer only. So BERT model is there, or Albert, Distilbert, some kind of a different BERT model are available there. So these are nothing but a transformer model, you can say. So what is happening now here is you are taking one kind of a transformer model and you are giving some kind of a data to it. Okay. So to get trained initially, now what you are trying to do is whatever data you are trying to give here is a label data, guys. It is curated by the labelers and you are trying to give that data. So it has a labels actually. It has labels with it, and you are trying to like just like our normal model building. We are doing the same way. We are trying to perform this model, but now the model is transformer model. Could be architecture like BERT, Distilbert, or some kind of a BERT, right? Or some kind of other transformer model is possible, like this one, VA. This is variational autoencoder model or autoencoder decoder model. Could be possible. VA model or autoencoder decoder model is possible, right? So what is happening is first time we are trying to give a huge data. Now the huge data is provided, huge data in terms of like try to understand. I'll give you explanation also when we try to give a huge data, like how to calculate parameter, how much the way we are trying to process the things, how the calculations are done, what is called as these parameters. Whenever we try to talk about the ChatGPT, people says that it is trained on the 30 billion parameters, right? 30 billion parameters, it is trained on something called as like 30,000 tokens, 30k tokens, 20. What are these things? We'll try to understand how it is coming to 30 billion parameters. What are they calling as a tokens? What is this tokens? What is the max token? Right? We'll try to understand this concept actually one by one entirely. What is this tokens? What is this parameter? How this parameter is getting trained? If we are trying to generate this parameter, or whenever I'm trying to generate this parameters, means nothing but guys kind of a weights actually. So we'll try to understand what kind of a weights they are trying to insert here on what is the calculation behind this 30 billion. Okay, I will explain you one by one. So it's going to be very interesting guys to understand the internal architecture. So let's imagine what is happening here. SFT is happening, supervised fine tuning. Supervised fine tuning is nothing but guys, initially you are trying to take one model. Okay, so you are taking one model with a small or not small actually. This is a label data. It's a huge data you are taking, and you are trying to train your normal model actually, a kind of a transformer model now. So what will happen is if you give this transformer model huge kind of a data. So now let's imagine you are trying to perform something called as a text generation task. Right? So you are giving this model this huge kind of a data, and based on the data guys, you will get trained entire your architecture. Like we have seen what kind of a positional encoder decoder model happen. So there will be two steps here. One will be encoder, one will be decoder. And when we try to pass the data, same data is also passed to the decoder. And that time it will try to perform an intervectorization. It is tokenized first, then it will try to perform a vectorization in terms of the label encoder. Then it will try to perform a positional encoder. Then there will be this kind of a let me draw it in proper manner. So let's call this as a transformer. What is supervised fine tuning? What is happening here? So this is the first step, SFT, supervised fine tuning. So we try to focus here. What happens in the supervised fine tuning? In supervised fine tuning, I'm taking one transformer model. So let me write it in a proper way. So this transformer model we are taking here. Okay. This transformer model we are taking. Now, just like we try to perform a normal our kind of a training of the models, we are trying to give this model entire the data, huge kind of a data. Now, this data will get passed on to two components. One is encoder, one is decoder here. And there will be something in between. There will be positional weights, right? Attention weights will be there, attention layer. So attention layers will be there. So this where we'll try to provide our data, this huge data will go as a tokens first. From token, it will get into the positional encoding by here. There will be two type of architecture will be there, like LSTM or some BERT model, plus artificial neural network will be there, which will try to understand the entire attention weights. It will try to create the attention between the words. You guys already know what happens. And then that input will be given here to the transformer decoder model, and same time the whatever data we have given positional encoding data, same data is also given here. And then after that there will be again the same LSTM layers will be there, and or GRU layer plus artificial neural network, which will try to generate a text, right? It will try to generate a text. And now what is happening is now, so whatever transformer I have created guys, now this transformer will try to generate a text, usual text. So whatever text it is generating, it is a usual text, but it is not a prompt actually. It is not the prompt, or it is not like the human language. Correct. So whatever model we have taken as of now, it is just trained on the huge data. Now you can pass on anything, or you can try to generate a data. It will try to generate a text. Now what I want to build something called as question answers, right? So I'll be asking one question, and it should be able to give me some answer, right? That is my main problem now. So when I'm trying to perform a traditional learning of this model, that is called a supervised fine tuning. So I'm going to give a label. I'm trying to give my entire huge data set, and I'm trying to build this kind of a transform model. My model will get trained, but it will be able to generate a text, or it can transform one machine language to the other language. But whether it is trying to perform a chatbot question answer of a thing, no. So that is not happening as of now, right? For that purpose now, what I have to do? I have trained my model. Basic knowledge is given to my model. That basic giving knowledge or trying to train your model is called as something called as for supervised fine tuning. Supervised fine tuning means you are trying to give your data to the model. You try to train one base kind of a transformer. So that data could be huge kind of a data, and you guys know already how the transformer get trained. But it is trying to perform a task which is told to that, right? It can generate the text, it can perform a machine level translation, but it is not trying to perform something called as question and answers, right? So you will be asking the just like the ChatGPT, we are asking some question, and the human is asking some question, and on the basis of that, this bot is able to give us a answer in written. That is not happening actually. I want to build that kind of architecture, right? Now, because my base model is ready, but now it is not working as a bot now. So what I have to do is I have to perform something which will be able to convert this entire architecture into a question answer kind of a thing bot, right? So for that purpose, guys, then the second thing comes into picture, which is called as mimicking the human preferences. Mimicking the human preferences means this is where it is called as human feedback reinforcement learning. Reinforcement learning, RLHF or HFRL, whatever you want to call this, right? Reinforcement learning with the human feedback. Now, what is happening here? Let's try to understand here. So what is happening is, so in this case, guys, this is I will give you just guys the shortcut as of now, but we'll try to go in detail. Like, so I have a detailed slides, just like I shown you. We'll try to understand how the human feedback is getting generated actually. So I'll try to answer that question in detail. Okay, don't worry. So we're trying to take a overview as of now for the ChatGPT training process, right? So first I have trained my model by using the SFT, which is a supervised fine tuning, where I have created a huge chunk of a data and I have trained my model, but that model is not performing just like the question answer chatbot, right? So that is the second step, which is the problem for me, right? So I have a model which can generate the text, which can perform the task, which can perform a machine to machine level translation, which can predict the next word, it can generate the summary for me, or it can perform a different sentiment analysis for me. But as of now, it is not trying to perform just like the bot, where I am asking one question and I will be able to get a human language kind of a responses, right? So for that reason, what happens is, guys, now what happens is, let's try to understand here. So now I have to generate one kind of a data here, corpus. So that is called as tokens now. Tokens. So I have to generate some tokens now. What is tokens now? Let's try to understand. Tokens means, let's imagine this is a person A. Now person A is speaking to a person B. Okay, guys, as of now, I'm trying to tell you in very, very simple manner. Okay, actually these steps, because you guys should be aware of what is happening. That's why, but like, don't quote me like you are told a very, very simple way, but actually it is something very different, right? No. I'm just trying to give you hint like what is happening here in the step 2, right? When we're trying to perform a reinforcement learning with the human feedback, what is happening actually. So I try to simplify the version. So, but when I would like to go in detail, I will explain you step by step, like what exactly happening here, okay? So then in reinforcement learning human feedback, guys, what happens is, let's imagine the person A is talking to a person B, right? So person is talking, let's imagine they are talking about this kind of a things. Let's imagine about the elections. About the elections, that who is going to be in an election on 2024, right? So obviously, when you are trying to build a bot, you are trying to ask this bot, right? Or let's take this example. This is not our relevant example. Let's take our example that we are trying to build a bot. Now, this human A and human B are there. They're talking about the stock market here, right? They're talking about the stock market. They're saying now recently Tata has launched IPO. What do you think? Like, what will be whether you're going to buy that? What is the Tata? Like, it will try to start a conversation, right? So, are you investing here in the stock market? Then what kind of a shares you are looking for, right? Then they will try to talk about the recent development which is happening in the share market. So they are talking about the Tata, which has recently introduced these shares, and there is IPO happened, and they will try to talk about this. And now what is happening after conversation after 30 minutes? When try to perform a conversation after 30 minutes, they will ask, this guy will ask one question. So the other guy, person 2 and person 1, this is a conversation happening, right? So the person 2, guys, person 2, what is happening? Person 2, first person 1 ask one question, person 2 will try to answer that, right? So you will try to answer that. Then this guy will again ask a question, this will try to answer that. Then this guy might ask a question third time, and this guy has to answer, right? So this kind of an entire corpus is getting generated, right? Entire corpus of the data is getting generated. Now that data, guys, now whatever the data generated between the interaction between the two human beings, right? Two human beings, that is now combined, that tokens, that is called as now tokens. I will explain you what is token in detail, like. So when we're trying to understand this concept of the prompt engineering, so what is happening is, now I am trying to perform a tokenization. Tokens means what? Try to understand. Tokens means the small sentences or words, okay? So I'm trying to create these tokens now. This is entire corpus. Now I am going to mix that. So this is called as, now this human language interaction has been done and the data is generated. This data is now, guys, it is trained. Again, this data is taken and it is trained with the original data. So like what is happening, like initially if you're trying to build a financial bot, that financial bot will be trained on the finance data. So huge finance data we have trained upon, right? Like you are taken entire data from the Bloomberg, all right? So Bloomberg is holding all the data. You have taken all the data and you have trained your model from the Bloomberg, right? So that is why we have a Bloomberg kind of a GPT model, right? If you remember, guys. So there is recently Bloomberg ChatGPT kind of a model has been released, which is called as Bloomberg GPT, right? So this GPT is completely trained on the financial bot. This is a financial kind of advisor. It is completely trained on the finance data. So we have created one transformer here in the SFT model. In the SFT, we have trained our model on the entire Bloomberg data. And now this model, it should be able to perform a human-like interaction. So what happens is, we try to take the two human beings and trying to interact with each other about the same topic, like financial topics. And then whatever the data generated, we are trying to combine that data with the original data. And then we are training here our models. Okay, then we are training. That is called as now reinforcement learning with the human feedback. Now, that is not enough, right? This is just a simple step. Now, reinforcement learning means what? What is the human feedback means? Try to understand. Here, now what will happen is once your model is trained, right? After the SFT, plus it has been fed with the human interaction data, right? Human interaction data. Now your model is ready, right? It can understand the questions and it is ready to deliver you the answer, right? Now what will happen now? So at that time, one human will be sitting here, literally one person, right? A human will be sitting here and human will try to talk or interact with the LLM, large language model. So there will be interaction between human one and the large language model which you have trained. Large language model for the financials. Now they will now this human will ask one question to this model. Whatever question will be there that related to the finance domain only. So it will ask like how is the stock market looks like today, right? How is the stock market looks like today? And then on the basis of the data, guys, which has been trained, this large language model able to generate one answer, right? So generate one answers, and on whatever answer it has generated, guys, based on that answer, this human will try to give it a reward or penalty. Now you guys already know what is reinforcement learning, right? Reinforcement learning means, guys, let's take a very simple example. Like if you are trying to train your dog, right? First time when you are trying to take your pet, or let's take the example that you have a dog pet at home. So at that time, what happens? So you try to train your dog, right? How you train your dogs? Like you try to tell your dog to perform one action, right? So if that dog perform that action correctly, correct? It is trying to perform that action. Let's say you will try to throw one ball. You are trying to throw one ball, and whenever you try to throw that ball, if your dog fetches that ball, you say, "Hey Rocky, go and bring that ball," right? So you'll throw one ball and it like this way, and if you try to fetch that ball and bring you back, right? So that means it is trying to perform a desired action. So at that time, you will try to give a reward to your dog. What reward you will give? You will give a food to that dog, whatever food it likes. Now, the second time, so you are saying that after throwing the ball, you are saying, "Hey Rocky, shake hand," right? Shake hand. Now, what is happening? It is supposed to raise his paw and it is trying to shake with your hand, right? That is what the action required. Now, this time it is failed to understand. So at that time, guys, you will try to hit your dog, but very gently, like, "Hey doggy, you don't understand this. Please try to shake," right? So this kind of a penalty you try to give. The same kind of an environment is created here, guys. Same kind of environment is created here. Whatever the large language model, which is got trained on your financial data, huge financial data plus the human interaction data, human language data. Now the person is actually sitting over here and it is trying to interact with your large language model. Whatever the interaction coming out, whatever the output will be coming out, that output will be measured and evaluated by the human being. That will be evaluated by the human being. It will try to give it a reward if it is trying to perform a desired action. And if it is not able to perform a desired action, if it is trying to generate some kind of a misleading output, some miss output, right? So it will try at that time, it will try to give a penalty to that model, right? So based on that, guys, based on this feedback, now that is called as human feedback. That is called as human feedback actually. Human feedback means human is giving a feedback to the outputs which is generated by our large language models. Correct? So until now, we have reached to step 2 now. In step 2, what happened? Two steps are happened. Once we have given a human language data, human language interaction data to our model, and our model is already pre-trained on the financial data. Now this large language model, now it is been evaluated by the person, a person sitting here, P1, and this P1 try to interact with your model, whatever the output is trying to give, if it is giving a correct output or desired output, just like the human being, less thinking in the way that if this would have been a human being, how it would have interacted, right? So that kind of a parameter it will try to take into consideration. Then it will try to give a feedback, reward model, right? Reward kind of a model. Reward model will come here. So I'll try to understand or make you understand that reward model, how it will perform. So reward model will be also performed here with the proximal quality optimization. Reward model is used to further fine tune your or improve your fine tune model, right? So now what is happening here? Here we are trying to generate a human feedback, and by using the reinforcement learning, that is why it is called as reinforcement learning with the human feedback. Means human is trying to evaluate the answers given by your large language model. And if it is trying to give a desired action, just like the human being, it will try to get a reward, otherwise it will get a penalty. Guys, right? So this is what the concept comes into picture. Third thing, second thing, and then guys, third thing is called as proximal polity optimization, which is in terms now using a reward model, guys. In reward model, what is happening is actually in reward model, now your model will get trained third time. Now what is happening is now your model, whatever the large language model, after the human feedback with reinforcement learning, it has generated the step 3. At that time, now we'll try to give it a desired action with the desired question. So if someone asks you this question, what should be the action you should be taking? So this kind of a pairing will be done, guys. This kind of a pairing will be done, and there will be multiple such pairs will be created on that data now. Now, if this situation occurs, what is should be the action? If this situation 2 occurs, what should be the desired action? That kind of a reward model is now generated, right? So probable, now it will try to generate the probable actions, okay, and probable action associated with the desired question or prompts, and that kind of a pairing will be generated. This pair they are trying to train your data. That is called as reward model. Again, it is trying to use the reinforcement learning. Since I told you proximal policy optimization is a algorithm for the reinforcement learning only. So now what is happening is, now instead of now giving single kind of a prompt mixture of the data, they are giving an entire pair of the data, that if this is the action, so or this is the situation, if this is the question, so this should be the action taken. Okay, so this kind of a pairing will be done, and then it will get fine-tuned on that supervised fine-tuned model which has been generated here, which gets human feedback, right? So that now get optimized here. That optimization will be done with the desired result. So pairing, like if the someone asks you this question, so this question, this is the desired result. This question, this is the desired result. So this kind of a pairing will be done, and that is called as a reward model here. So reward model will try to get trained your model here, and it will try to give a reward or a penalty based on this kind of a things. Now, how it will get a penalty based on the hallucinations, based on the wrong things, or it could be created a wrong result, or something called as something which is not matching with the constitution or legal things, right? Someone's asked the question that, hey, what are the sites available which can teach me to hack a particular website or hack a particular bank, right? So that kind of answer should not be answered. That kind of a question should not be answered, right? So if it is trying to answer that question, that is something is going wrong. Illegal things are getting generated, right? Or it could be kind of a personal information breach, right? So if you're trying to train your data, which is available on the entire website, right, on the entire internet, at that time some personal information is getting trained, and it is trying to breach some kind of a personality, right? So personal NPI Act, non-personal information, personal information act, right? So at that time, what should happen? It should not be happening, right? So that kind of a guard railing is called as, guard railing, kind of a thing, which should be available, right? So that is what it is taken care here. And then guys, your model is available. All right. So I think everyone is now able to understand in total, like what is happening, what is supervised fine tuning, what is the reinforcement learning with the human feedback or mimicking human preferences, then proximal polity optimization, right? So now what we'll try to do is we'll try to understand these components now. So how to perform prompt engineering, how to perform this fine tuning, how to align with the human feedback, how to evaluate model, this we'll try to understand now. I think you guys are able to understand. This is the same step, guys. This is the same process I have talked about. So this is what I already covered now. So we have taken the same thing. Like this is our reward model. This is our supervised fine tuning model with the proximal orientation, and this is our SFT model. All these steps we have now understood how the entire ChatGPT getting trained, right, in the 3 processes, guys. So meanwhile, guys, if you have any questions, any doubt, please you can interact with me. I'll try to answer you, okay, accordingly. So now let's begin with one by one. Now try to understand what is the prompt actually, and what do you mean by prompt engineering now. So what is a prompt? Now no need to tell anyone, right? So you guys only tell me what is prompt now. What do you mean by prompt now? You guys already understood, right? So can anyone tell me what is the prompt? And then we'll try to talk about this kind of a prompting methodologies. So what is called as 0-shot learning, 1-shot learning, and few-shot learning. So can anyone tell me like exactly now what is prompt, and now what is the prompt engineering then? We'll understand in detail, but what is your understanding, guys? What do you mean by prompt now? And what is the prompt engineering? What do you think? I want to know your opinion, guys. Please tell me, what do you think? What is prompt now? So let's try to understand. that what is your understanding about the prompts now? Yeah, guys, who would like to answer me? What is prompt? What do you mean by prompts? What is your understanding? Let's have a couple of answers from you guys so we can start building our knowledge around it. The way we communicate with LLM. Awesome, Archana. Correct, correct. Anything else, guys? Anyone else who would like to try? What is the prompt now? Okay. Prompt done immediately without delay. Prompt, okay, okay, man. Okay. Prompt means done immediately without delay. Prompt, that prompt we are talking about. Oh, okay, awesome, man. Yeah, correct. The prompt, but here they're trying to understand prompt is like some different way. All right. What else, guys? Who would like to answer me quickly so we can start our further discussion about the prompt engineering? Yeah, guys. Please let me know. Oh, guys. Mohammed, you are raising your hand. Then please let me know. Mohammed and Mohammed, Rahman, Sophie. So please let me know. You can interact with me in the chat box so I can take it from there. All right, guys. So if you try to understand what is a prompt, let's try to understand this way. Now, prompt means nothing but, guys, is a query. Prompt means nothing but a query. Now, what is happening here? Let's imagine this way. Okay? Perspective to ILM. Okay, interactive language learning. Okay. Okay, guys. So let's try to understand what do you mean by prompt now. Prompt means, guys, in simple way that the way we are trying to interact, right? Develop and refine AI generated text prompt that meet the needs of the client. Awesome, awesome, ma'am. Aisha, ma'am, correct. Okay. So this time you are get it very correctly, very, very technical answer. Technically very correct. Okay. So guys, in short term, let's imagine that if I want to tell you what do you mean by prompt is guys nothing but the way you are trying to interact with the LLM. LLMs is how you are interacting with the LLM by one kind of a query, and this query is sent in terms of a text, right? So you are sending one text query in terms of one kind of a text. You are writing one sentences, and that sentence has to be understood by the large language model, right? So that is why we are giving this kind of a human corpus data, right? Human interaction data. So that is why you now understood that why we are trying to generate or create that kind of a steps, that why we are training our model with the human interaction, because whenever we are trying to take this entire application, at that time, the interaction will be done by the humans in their human language only, right? Human language only. In human language, they will try to query the LLM, large language model, and that query will be in the terms of the text, like normal language text, and it will try to interact with the system. So that text or whatever query we are passing here, that is called as prompt. And then construction of this kind of a prompt, guys. Construction of this point of a prompt, which is called as now prompt engineering. Now everyone understood what is prompt engineering, why it is important now, right? So why prompt engineers are getting the salaries like 3.5 crore or 4 crore. Now it may be you guys might have understood, and you come to know like when we'll further go in the detail that what kind of a parameter, billions of parameters generated. Now that is why, guys, if you try to say here that whenever we talked about the tokens, right? So this 30,000 tokens or 4,000 tokens, 5,000 tokens, 30,000 tokens, this is what the tokens are given. Tokens is nothing but kind of a prompt only, right? So this kind of a probable prompts have been given for the training purpose, and that prompt has been crafted very, very meticulously by the humans or some kind of a model. I will tell you what, because one point of time, what will happen is like we understood in the human feedback, guys. So when the data is getting very, very huge, at that time, the human capability will fail, right? So when you try to interact with the large language model as a single person, it is not possible to interact and get an entire answering question, getting evaluated, right? So means whatever the option, whatever the output generated for the single person, it is very difficult to analyze the entire model. So instead of the human, actually, they will try to build one model there. They'll try to build one actual model, which is a binary classification model, which will try to classify based on the output, whether this output will get a reward or get a penalty. So I'll explain you in meantime, right? So let's try to understand what is prompt. Prompt means something which is called as, guys, a way we are trying to interact or query, you can say. The query is nothing but a kind of a text you are writing in return. You'll get an answer from the large language model, and to create this kind of a prompts. So that is called as prompt engineering, right? In prompt engineering, what happens is, guys, whenever a LML, this large language model, right? So this large language model, whenever they're trying to give you inferences, means result actually. They're trying to understand the context of this prompt actually. Context means what is the reasoning you are trying to do here. And based on the context, guys, based on the context, it is trying to do a fulfillment actually. a fulfillment of the text, actually fulfillment. So at that time, whatever the inferencing means whatever the output it is generated or trying to complete the instruction given by the prompt. Okay, so that is called as context learning. Actually, context learning means, so let's try to understand. If I am trying to ask this financial bot, right? So this financial bot I am asking, what is the what are the top 5 stocks today which are performing very well today, right? So what I am trying to ask here, I am trying to talk about the stocks, and then I am trying to talk about the prices of the stocks which are now getting traded very high prices today, which is getting traded on the high prices today, right? So the context out here is the stocks. I'm trying to talk about the stock prices, right? So this context, if I'm trying to understand that context by using the prompt, and in return I'm trying to give you a output. So that kind of a learning is called as context learning. Okay, so context learning, how it happens is, like, try to understand. There are 3 approaches for the context learning. One is zero shot learning, one is one shot learning, one is a few shot learning actually. So what is zero shot learning? Let's try to understand. Zero shot learning means, guys, so let's take the example that if you're trying to perform a zero shot learning, at that time, guys, your LLM, whatever the LLM is there, whatever the large language model is there, initially that large language model, you are not responding, okay? So whatever the prompt you are passing here, right? You are passing something called as prompt here. So you are passing one prompt to your large language model, LLM model. So whenever you are trying to pass this prompt to your large language model, a kind of a query, you can say that prompt. So for that prompt, guys, whatever the prompt you are called in, okay, for that prompt, whatever the prompt it is trying to give you, okay, so based on the prompt, based on that instruction, okay, based on the instruction, it is able to give you a desired result. If it is able to give you a desired result without giving any further example. So you are not given any example that what kind of result I have to give, right? So you're not providing any kind of an example to your model, but if it is able to give you, if you are able to provide any prompt, if you are able to give any query, and that instruction is understood and it is trying to give you a desired output without giving any kind of an example, that what kind of an example you have to provide. So that is called as zero shot learning. Zero shot learning. Okay. So let's try. I know it could be something confusing. Let's try to understand. So you will say that my model is already trained, right? So already trained, but it should understand the prompt, right? So if I'm not giving any prompt examples here, so what kind of a prompt example? Even though I am giving a human interaction data, but I cannot give an exact prompt to my model, right? So what exact prompt will come, then you have to interact, right? At that time, this model has to evaluate, it has to generalize itself. It has to generalize on based on, like, simply you can say zero shot learning means out of syllabus question. So whenever we try to appear for our exams, right? So some question will be out of syllabus, and how you answer this question based on your generalization of the learning, right? Whatever the chapters you have learned, we'll try to mix match something and we'll try to answer this question. So, but have you ever got any kind of a model answer for that question, right? You have not got any model answer for that question. WhatsApp link, yeah, Amar will share with you guys. Rudra sir, Rudra Koteshwara Rama sir, the Amar will give you a link, okay? WhatsApp link. He will share in the chat box. Amar, please, can you share the WhatsApp link with the colleagues in the chat box? Okay.
WhatsApp?
Someone is Rudra sir is asking for the WhatsApp link. Maybe you guys are having this as SDP link, right?
Okay, yeah,
sorry,
sure.
FDP link, sorry. WhatsApp link. Please share with the chat box. Okay? Okay, guys. Guys, what is happening is zero shot learning. So we have understood what is prompt. Prompt means what? Query. So whenever we're trying to craft this kind of a prompt, model questions, you can say model questions, and based on this model question, what should be the answer given, right? This is what we try to understand here. Prompt means nothing but a kind of a model question, you can say. So if this is a question, then you should be able to answer them. That this is called as prompt now. Prompt is given by the users. Now, once we are trying to generate this kind of a prompt, that is called as prompt engineering. Okay, prompt engineering. Now what is happening is, guys, so whatever based on the prompt, if your model able to understand the context and it is able to give you a desired reader, that is called as context learning. But in the context learning, what is happening is there are different approaches which are available, right? In the context learning, one is like you are giving some kind of an example to your model. So what kind of a prompt you may expect, and based on that you can give a result, or you can give a couple of more examples, and then you can tell your model that this is what the you can expect, and this is what the answer you should be able to give. Now there will be 3 approaches. One is called as zero shot learning, which I talked about, the out of syllabus question, right? Out of syllabus question comes to your question paper whenever trying to appear for the exam. At that time, how we try to understand this question? We try to generalize our information or whatever the knowledge we have, whatever the chapters we have learned, right? Based on this chapter's knowledge, whatever the knowledge we have, we try to generalize that, and then we try to answer that question, right? By taking the context into understanding. So same way, guys, zero shot learning means, let's take the example that I am asking my large language model that this is the comment actually. I love this movie. This is what I have passing, and based on that, it should be able to give me the sentiment, whether it is a positive, negative, or whatever the neutral sentiment is there, right? So guys, zero shot means LLM has no idea of the answer. No, it's vice versa, sir. Archana ma'am, sir, it is vice versa. So that zero shot learning means it don't have an idea of the question actually. It don't have an idea of question, what kind of a question I will be asking or what kind of answer I am supposed to give. So it has all the data means, but it don't understand the answer means it has the data, but it has a no model question or answer kind of a format at that time, right? So because you are giving a data and something come out of that data now, or you can take this zero shot learning as, so you have a given data, but whatever the question coming, it is not available. Answer to that question is not available in that data, but it is trying to answer that question using, or that prompt using its generalized knowledge which is available on the data. That is called as zero shot learning. So means, let's take this simple example. And if I am simply giving a comment, you will understand, guys. I'll give you both the examples along with this zero shot learning, so you'll come to know what is happening. So let's imagine first I am just passing my prompt here. What prompt I am passing here? I love this movie. Please classify this review. This prompt I pass. So it should be able to give me the result, whether it is positive, whether it is negative, whether it is a neutral, right? So this kind of a things is called as zero shot learning. Let's try to differentiate with the one shot learning. Now what is happening is, when I'm trying to train my model, what kind of a prompt I am giving? I am giving this prompt that I love this movie. Please classify this review, and what is the sentiment here for this is positive. Now next time what is happening? Now I am giving a prompt for the testing purpose. What prompt I am giving here? So I am giving, can you please classify the below review? I am writing review, I don't like this chair. So you should be able to give. Now what is happening here? I am providing the labels. I am providing one kind of an example actually. So here I did not provide any example here. There was zero examples. I told it that whatever data you have, based on that you try to come up with the answers, right? So here, but I am trying to give you one model answer and question here. So I am giving one prompt, and for that prompt I am giving you answer as well, right? So answer is given, a prompt is given, means a question is given. That is only one example I have given. Based on that, it has to produce all the future answers, according to one example only, one shot learning. That is called as one shot learning. Then there will be something called as few shot learning. Few shot learning means, now this time what is happening is I am giving more than one example actually. I am giving more than one examples for the training purpose of the prompts and answers, right? So whatever these prompts I am giving more than one example. Let's try to take this example here. So first example what I gave you, that I love this movie. This is a positive sentiment. This is, please classify this review. Then I gave a review. I told us a answer as well. Answer that this is a positive review. This was the first example. Then I gave second example here. So I gave this example was for positive review. I gave also example here for the negative review. So what I told there, please classify this review. I gave a prompt that I don't like this chair, and this is a negative review actually. So this both the examples I have given here. What I have given here, more than one examples. So could be more 10 examples I have given. At that time, then third time I am asking it a question, who would use this product? Okay. So please classify now. So who will use this product? I am tweaking my question now. See here, I am not asking the same question. Like I gave one positive comment, I gave one negative comment. First, I gave only positive comment here. Then I asked it to classify the negative comment, right? So it should give me negative comment, negative kind of a sentiment. Here, I did not give any example. No example was provided here. So that is called as zero shot learning. Here, only one example was provided, but that too only one category here. That is positive category example was provided. Then I tested it with the negative category, but the same kind of a prompt, but now category is negative, but it should be able to answer me. So that is called as one shot learning. And then something called as more than one prompts are given, more than one examples are given, like this way. In the third example, where I have given example number 1 for the positive review, the example number 2 I have given for the negative review, and now third time I am giving a ambiguous question here. What kind of ambiguous question I am giving? So classify this review, who would use this product, right? So it has to tell me this neutral, right? This kind of example. So this is called as few shot learning. Clear now? What is few shot learning? What is zero shot learning? One shot learning, right? So prompt engineering means nothing but a query, and to craft this kind of a prompt. So which can be given as an example for the zero shot, one shot or few shot learning. Based on your approaches of the context learning, you should be able to understand. Then after few shot learning, can LLM generalize? Yes, guys. After few shot learning, it will generalize. Or even some models are available which are able to perform a zero shot learning actually. So most of the LLM models are also trying to perform on the zero shot learning as well. So because they are trying to give an example beyond its data, beyond this cutoff time. Okay. So that is why then we'll understand the RAG thing. Okay. In the end, we're going to understand. So to take care of this kind of a situation, we have something called as a retrieval augment generation. So we'll understand how to use this vector database here and try to create this kind of a problem. It depends on the prompt you are using. Sorry, I am not able to understand what you are asking, ma'am, exactly. I think it depends on the prompt we are using. Means what? Please, can you elaborate your question so I can take it? All right. So, guys, now we have understood. So, what is zero shot learning? What is one shot learning? What is a few shot learning? All right. So, let's try to take an example. Next example. Now, everyone is clear what is prompt and what is prompt engineering. All right. So, there is something called as context window, guys. Now, what do you mean by context window is? So, context window means, guys, it is trying to maximum. So, it is kind of a limit actually. So you're trying to define one kind of a limit that within what limit or maximum number of token that LLM can be provided. Okay. So that limit means let's imagine 30,000 tokens or 20,000 token. Token means prompt, guys, kind of a prompt. And based on that and based on this kind of a learning, how it should be able to generalize this kind of a thing. So that is called as the context window. Context window means how much information or what is the length you are providing here from the prompts. Depending on that, guys, it has to create this context window. Actually, you have to define the context window. You have to define the context number, then the referential. This kind of a settings you have to perform in order to generalize the inferences. All right, guys. Now let's try to understand the next thing that there are actually two approaches. Okay, so one is like a greedy approach and one is random sampling approach. So whenever we trying to, let's take the example that whenever we trying to generate a word or generate a kind of a response at that time, what is happening? We are using this kind of activation function here, right? So we have understood the prompt that how the prompt is doing, what is the zero shot learning, one shot learning, and few shot learning. At that time, what is happening is when you are trying to create this kind of a response at that time, so there will be two approaches which will be used, guys, to generate the response. One will be called as greedy approach or greedy sampling. One will be called as random approach. Okay. So what is greedy approach or what is random approach, sampling approach? Let's try to understand now. So what is happening is greedy approach means, guys, let's imagine that now let's imagine you have passed one sentence that I love to eat. Okay. So this means sentence I have written here. Now you have to generate a text. What will be the next text? Let's imagine I already provided some kind of a context here, right? So context means one kind of a context window I have provided. There I have provided some kind of a sample prompts here, a sample data I have provided, like what kind of a data. Based on that data, guys, I will try to populate some kind of answers out here, right? So based on that, let's imagine that I will try to populate something called as now cake, donut, banana, or apple, or could be multiple things will be there, right? Now what is happening is here, whenever we're trying to pass these things, okay, these words, and there we are having something called as softmax operation here, softmax activation function. Now, softmax activation function will generate a probability, guys, for every word. So, what's gonna be the next word here? So, at that time, what is happening is, so this softmax function will give a probability. Let's imagine the cake got a probability of 0.2, the donut got a probability of 0.1, and banana got a 0.02, and then apple got 0.01. Now, here, out of these words, whatever the maximum probability is there, like this one, 0.2 is the maximum probability. Now, this word will be taken in spite of whatever the reference, whatever the attention is there, whatever having the maximum probability, so that one will taken. So I would love to eat a cake. So this is how the cake will get entered here. So that is called as, guys, greedy approach. So greedy approach, we are taking the largest probability first. The word or the token with the largest probability will be taken, and the basis of that it will try to fulfill the things. Or now in the second approach, guys, which is called as random sampling. Now what is happening is, rather than going for the highest probability, now word is whatever the word will come into picture, guys, for the next word here prediction. So now it will try to take based on the random weighted strategy. Okay. So random weighted strategy means what will happen is, let's try to understand here. So it will try to perform rather than going for the highest probability, guys, rather than going for the highest probability, it will try to take a action according to the some kind of a random weightages will be created. So some random matrices are created actually when we try to perform this kind of encoding. At that time, whenever we try to perform something called as attention matrices, at the attention matrix or attention weights which we're trying to create here, at that time, one kind of a product vector we'll try to insert here. I will come to know, I will explain you this randomization vector which will be inserted here. Along with this attention vector, there will be some kind of a vectors will be given, random weightage vector. So this is one kind of a learning actually, how it will try to perform something called as a proximal quality optimization. I will explain you at the time. So let's try to understand. This is kind of a vectorization method will be provided. Based on that, some random weights will be given. Some random weights will be given. I'll explain you later. And based on that, rather than taking for the highest priority, guys, it will try to select something called as randomly some different random weights rather than going for the higher weights. And if you try to choose, let's say, imagine it is going for 0.02 weight. Okay, this weight based on this vectorization. So it will try to choose banana rather than cake, which is the highest priority. So that kind of a random sampling will be done. One, it is going for the highest priority, or it can do a random sampling. So rather than going for highest, it will try to take a random guess. All right. So there will be two approaches using which it will try to generate the things. Now, so to perform this kind of a generation, there are actually some other methods as well available. We have understood this concept. We have to understand here. So we have already understood what is context window. Context window means nothing but, guys, it is the maximum number of tokens limit, or this we have to define here while we trying to fine tune this model. So context window is nothing but a maximum number of tokens that model can consider, right? So or the kind of a prompt which can provide here. So for the training purpose, okay. And now this contents of both prompt plus responses, guys. So whatever the responses we are providing and whatever the prompts we are providing, both the numbers are taken care, and accordingly the length will be set. That length will be context window, okay. So this is what is called as context window now. And then something called as maximum token. Maximum tokens means a kind of a parameter where we have to consider that what kind of a tokens will be taken here. That is talking about the prompt actually. So how many prompts will be trying to take here, and that will be fitted into this, that prompt will be fitted to this window actually. Whatever the context window we are trying to define here, according to that context window we'll try to define our max tokens actually. The max token has to align with this context window only. So max token means how many maximum tokens will be utilizing for the training purpose. Kind of a prompt actually here. So this is consists of prompt plus responses. This consists of only prompts actually. How many maximum prompts will be taken for the context window, okay. Then something called as now temperature. Temperature I already told you. So whenever we try to perform some kind of a greedy approach or kind of a random sampling approach, at that time the temperature will decide. So how to perform a randomization? This temperature will try to decide, guys, how the randomization will be done. So that temperature, guys, yesterday you were asking like how to set this optimal value for the temperature. That optimal value will lie between the range of 0 to 1, just like the probability range. So the more the temperature, there is a more higher the chances that there will be a randomization done. More randomization will be done. If the temperature is lower, then there is a less randomization will be done. So that is called as temperature now. Temperature is a parameter which will try to decide what kind of a extent of a probability I should be taking in order to perform a randomization for the generation of the words. So it is talking about the word generation probability, okay. So it the more is the temperature means more is the randomized generation. Less is the temperature means less randomized generation. Right. So there is another method also, like we understood, like random and biased one. So biased is greedy one actually. So greedy one is called as like taking the maximum probability, and the randomized one is taking as per the random probability. So there is something called as, you can create something called as some kind of a caps actually, top N or top P. So what is top N or top P means whatever the word or the token which will be selected as a result, right? So for that purpose, you will try to create one kind of a top N. Top N means what? So this N number, whatever the N number you are taking, let's say if you take top N as 3. So out of that, what will happen? Let's imagine here you have a 10 words here. So you have listed 10 probable words here, 10 probable let's say 10 probable results you are listed here. So if you're trying to predict the next word here, so for the prediction, like I would love, so if I'm saying, keeping this sentence that I would love to eat, and then out of that, let's imagine you are created 10 probable words which will get chipped in here as an next word. Out of that, I can create one strategy which is called top N. So if top n, if n value, if I am taking 3 means what will happen? Out of this result, out of this 10 result, I'll try to take only top 3 results. Top 3. And based on this top 3 guys, I'll try to generate my words. Okay. So in this case, I'll try to take only 3 words, the top 3 words based on the probability, of course. So whatever the highest top 3 probabilities will be there, based on that 3 probabilities guys, I'll try to take here. So cake, donut and banana. So if you imagine these are my top 3 probabilities. So top n talks about this thing. Top n means we're trying to cap our entire word generation up to top 10, top 5, top whatever n number you will taking. Up to that number, we'll try to restrict our generation of the next words or result. All right. So if I'm saying top n means top 10 out of top 10 words, I'm saying top 3. So top n equal to 3. Then I will only take the top 3 word, and based on this top 3 word, I will decide which one should go in as my next word. All right. So that is called as top n approach. And there will be top P approach. Top P approach means what will happen here? Rather than taking top 10 or top 5 or top 3 approach, now I am trying to do a summation of the probabilities here. So what I am trying to do is, if whatever the words are there, so everyone has the individual probabilities. This word has cake has probability 0.2. Then this donut has the probability which is say 0.1, and then there is a probability for banana, right? 0.02. And then there will be probability for, let's imagine this is for apple is 0.1. So rather than 0.02, let's imagine I'll try to take as a 2.5. Okay, 2.5. So what I'll try to do is, now I am trying to take rather than taking top 3, top 5, something like that, I'll try to take up to summation of some probability. I'll try to keep a probability summation a number here. So that number will be a P number. Top P probability means up to, let's say, if my summation of the probability goes up to 5. So if I try to add, let's say, this cake, then donut, and then the banana, it comes to what? 2 plus 1 is 3, plus 2 is 4, 5. 0.45, right? So plus, let's imagine this is something called as 0.05. So this next one will be apple. So apple has 0.5. So if I adding 0.05 here, so it will come up to top 0.5. So up to top P means up to top this kind of a limit which I am trying to generate here for the summation. So that summation, if that summation comes to this number, then I will try to stop taking the words. Okay. So means whatever the probable words I have here, I will try to generate like please take the words which are summing up to probability of 0.5. 0.5. So I try to generate, try to take the numbers when the number summation of the probability will reach to this cap which I am trying to create here. So once that cap is created, guys, that many words will be taken. Rest of the words will not be taken for the generation of the next word. That will be not the contestant. So in this case, it will go up to only these 4 words, not 4 words exactly. Yeah, 4 words. Cake, donut, banana, and apple. And here only I am trying to get my probability as 0.5. So the summation is 0.5. This is the cap I have given here. So top P, this is called as top P, top percentage, you can say actually. It is the top percentage, probability percentage. If my probability percentage goes up to 0.5, so I'll try to stop there. I'll not try to take the further consideration into consideration. All right. So this is called as top n and top 5. Top n means trying to restrict on the basis of the number. Now you are trying to restrict on the basis of the summation of the probability here. So a probability up to this number, up to this probability percentage, right? You will try to take this one. And temperature, we already spoken about. The temperature talks about the range of 0 to 1. So you have to take the randomization percentage. So according to the temperature high or low, it will try to perform a more randomization, guys. And based on that, your responses will be generated here for the prediction, text prediction. Okay. Guys, as of now, and then penalty means, of course, whenever you're trying to list, what is happening is here. So let's imagine here, this cake word appear, okay, as a next word. Now, once this word is appear, what I'll try to do, penalty means what? Try to understand here. So now, out of the other words, which word should again come afterwards, right? So for that purpose, whatever word appeared here once, I'll try to give a negative probability to that word. I'll try to associate kind of a negative probability so that again the same word out of my entire context, right? Out of my entire context window, which I have a different words available. If one word is already getting generated here, so I would love to eat a cake, and then I'm trying to write about the other sentences. At that time also, I'll come to my corpus, and from that corpus, I'll try to search for the words. So once the word is appeared, guys, I'll try to give a negative weightages, so that next time that word will not get repeated, right? Next time that word will not get repeated for the generation process. For the generation process, that is called as penalty here. All right. So we have understood what is context window, what is max token, what is temperature, what is top n approach, What is top P approach? Top P approach talks about the percentage. Top N approach talks about the number, like top 5, top 2, top 3. Here talks about the up to top probability percentage. Up to summation of this probability percentage we'll try to take, and temperature I will have spoken, right? So any question, guys? Any doubts as of now? So please let me know. Are you able to understand like what we're trying to understand here? This all concept is, guys, about the prompts only. So what is the prompt? What is the inferences happening? And what is this zero shot learning? And what is the generation happening at the time? How we are doing sampling? This approach we have understood only, guys. Okay, guys, please let me know if you have a question, any doubts as of now. Otherwise, I will go ahead then. Please give me a confirmation that you are comfortable with this concept as of now. So we'll try to go ahead. Now we'll try to understand actually what kind of a training will be happening here. Supervised fine tuning, right? Whatever the supervised fine tuning is happening at that time, there could be 3 approaches, guys, here. Okay. So there are 3 approaches actually here. Let's try to understand here. One approach is, guys, called as encoder only model actually. So one is called as encoder only model, encoder only. So there is something called as decoder only model, and then there will be sequence to sequence model. Sequence to sequence model where we have a encoder plus decoder, guys. Encoder plus decoder, right? So this kind of a 3 approaches are which are available here. So let's try to understand what is happening here when we are trying to perform a, guys, this kind of a pre-training. Means this, guys, this approach now you'll say that because you already told us that whenever we trying to train our model, large language model, we are taking the transformer model, right? And transformer model consists of the encoder and decoder approaches, right? All these approaches are already available. Then why you are saying this kind of a encoder model, decoder model, guys? This is I am talking about the pre-training of the model. Actually, if you are not taking any pre-trained model already, so how, if I'm talking about the model where you are not taking any pre-trained model, you are trying to train your model from the scratch. You are taking a base model and then you are trying to from the scratch, you are trying to train that model. That is called as pre-training large language model, right? So that model approaches I am talking about. So don't get confused. One is like you are already having a pre-trained model. You are taking that model. You are trying to fine tune that model. We'll understand what is fine tuning that model. Okay. Okay, Nalini ma'am. Okay, yes, okay, ma'am. I will tell your query to Amar and he will try to answer you. Okay. Amar will try to answer you over the phone. So please ping Amar the same query, ma'am, and then he will. Nalini ma'am, please ping this one, sir, ma'am. So we'll answer you. Okay. So guys, let's try to understand. So I'll not go into detail. You guys already know. So I will just give you overview. Yes. So what is happening is like when you are trying to take a model, okay, fine tuning foundation. Now this is the question actually I am trying to talk about, and then we'll try to understand. There are 2 approaches like I told you. Now let me go back to our model and let's try to understand which component we are trying to understand here. Guys, we just spoke about this approach, fine tuning approach. The prompt engineering approach, and in the prompt engineering we understood what is prompt engineering, what are the approaches available when we try to generate the things, right? Like a greedy approach, then we try to understand the randomized approach, then we try to understand top P, top N, right? And then we try to understand what is the other methods, what is the heat, what is the heating methods, what is the temperature methods, and what do you mean by called as context window, another thing. Now what we're going to understand is this component now. Okay. So this component we are trying to understand here, fine tuning, SFT component. So we are trying to focus on this component and then we'll try to understand, go back and try to understand this human feedback concept. Then we'll try to understand the PPO concept, proximal policy optimization concept, right? So now you try to relate that. Till now we have covered this one. Till now we have seen this. This is what is happening actually, what kind of models are there. And then I will try to answer this question like whether we should go for the pre-trained model or whether we should go for the scratch model, right, from the beginning. Now guys, try to understand there is something called an encoder model. What is happening is you have a data in the terabytes, petabytes. You already know what is terabyte data, what is the petabytes data, right? So that data, guys, will be passed on to one kind of a filtering actually. So what happens is whenever you have a unstructured data, guys, unstructured data, that unstructured data cannot be passed as it is. You have to perform some kind of a filtering, and once you perform a filtering, guys, that the data will be now stored into kind of a positional encoding, numerical encoding, kind of a tokenization, and then from the tokenization there will be embedding happening, and then you will be passing your model, right? So this is what we have seen actually. So what happens is we are trying, whenever you have a data in the gigabytes, in the terabytes, petabyte, that huge data you are passing here. So then we'll try to apply one kind of a filtering here. And once we apply the filtering here, so let's imagine whatever the sentence you are taken here, one sentence that teacher teaches the student. Now what will happen is now there will be encoder model. So for every word now, for every word, it will try to mask that word into kind of a numerical number. From there, it will try to do a positional encoding. And then guys, let's imagine that you are trying to generate a word here and try to understand the attention here. So what is the attention between the word like the teacher and the teachers and the student, right? So at that time, what will happen is they try to mask something called as the hidden state actually. Hidden state, okay? Something called as try to do a hidden state positional encoding. A vectorization will be done. At that time, what is happening is simple encoder only model. They're trying to mask the thing. And guys, then once we try to entirely perform this kind of thing, then there will be a bidirectional transformer. Means what is happening actually, we have a forward propagation, then we have a coming back again having a backward propagation. Now this here, what is happening is in the forward propagation, guys, rather than going only in the direction, we are coming back in the direction also. Means what is happening is we're trying to take the last word first and then try to understand the relationship with the previous word. So this is what is happening in the encoder model actually. So usually what is happening, we are taking one words each here and then we're trying to convert them, trying to perform position encoding. Then we are talking about what is the next word will be generated. Now, rather than just focusing on only one direction, now they're trying to focus on both the direction. Now, what they're trying to do is rather than starting from 0 position going up to n position, they're starting from the n position first. And then also both the ways, like from n position, like last position word argument, from there it is trying to understand the student, then they're trying to understand this context of the word and attention word, and then trying to create an attention weightages here, and then they're going back. So they're going this direction as well, then trying to create a attention weightages, attention thickness, right? So which we have seen, and that kind of a modeling is called as, guys, encoder only modeling with the bidirectional. So that is why this word is called as bidirectional encoder representation. Bidirectional encoder. Okay, encoder representation transformer. So here we only have an encoder only model, right? So that these are the example, BERT model or robot model or distill BERT is also there. Distill BERT model is there. So there is a two-way communication happening here. So they are doing two kind of a forward propagation. One, they are going in one direction. Then they are starting from the last index. They are coming back also, and then trying to find out the attention weightages, position encoding, the relevance and all. And then they are trying to generate the last word, guys. All right. So this kind of a model is there, which is called as encoder only model. All right, guys. Amar has shared the attendance list, and the feedbacking it is the same, guys. You can mark your feedbacks. Okay. So guys, this is encoder model only. And what are the use cases like sentiment analysis, name entity recognition, word classification? For that purpose, we are trying to use this kind of a model. Now there will be one model which will be decoder only. Before that, I would like to answer this question that what is happening here. Let's try to understand here. So when I'm trying to take both approaches, one that you can take a pre-trained model. You can take the pre-trained model. And second is you can start like from the scratch, right? Like this is how we are trying to do. Pre-training your large language model. So we are trying to do on our own, starting from the scratch. We're trying to train the second approach, right? So guys, now the question is whether you should do a fine-tuning of the foundation model versus pre-training of your model, right? So whatever the model is there, you're taking that model and then fine-tuning that model, or whether you are trying to train your model, pre-train your model from the scratch, right? That is the question actually. So guys, if you want to perform some kind of a fine-tuning, then what you have to do is you have to download some pre-trained model like GPT 3.4 or GPT 3.5 or 4 model, or then Hugging Face, there is an entire model hub, which are different models available, right? So guys, then once you have this model, now we have to decide like what will be the training data and the model size. Now what happens is, like I told you, whenever we have unstructured data, only 2 to 3% of the data will be useful. Otherwise, some data will go in the filtering purpose, right? So that is one thing, and the data will be in the petabytes. The size will be in the petabytes. Like you are trying to train from the entire internet, you are trying to take the data, right? So it will be from the petabytes. And then guys, the basis of this data, right? Basis of this data and the data format, guys, your number of parameters will be decided now. So let's try to understand whenever you're trying to take the data, guys, this kind of a model, these models are creating something called as 30 billion, 7 billion, or kind of a 10 billion parameters. So now you have to understand billion parameters means what? This kind of a weightages. this kind of a weightages and this kind of a biases, because our equation, which is like a wx plus b, guys, at that time what is happening here, and we have understood here, guys, that whatever the weights we are trying to create here, we are having attention weights as well. So we have understood that whenever I am trying to create this kind of a sentences, that teacher teaches to the student, the whether the or teacher teaches the student with the book, right? This is what the next sentence we have to generate, with the book. So whether the teacher is now having a book or whether the student is having book, right? So this is what the next word we have to generate here, correct? So for that purpose, now we have to understand the entire relationship between the teacher, the book, and the multiple relationship we have seen, that multi-head attention. So that is what we spoke about, multi-head attention and single attention, right? So we have to create some attention weightages. So that weightages are different. Then our normal weightages, what we try to do a forward propagation, that weightages are different. Then we have understood the entire forward propagation, which uses the base model like BERT model, LSTM model, GRU model, plus artificial neural network model. And when we're trying to inculcate this kind of a tokens and all, that comes to around 30 billion parameters. So now you have to decide whether you have a capability to train this kind of a 30 billion parameters, which will require how many cycle. I will explain in the calculation, how many floating point equation it will require, how many hours it will require, what kind of energy it will require, what kind of a GPU hours it will require. Now you have to understand this equation, and then you have to make a decision, like whether you want to retrain your model from the scratch or whether you want to go for the open source model. Then you want to fine tune that model. Fine tuning means what? Simply you taking this model which are available, which are pre-trained, and you are trying to customize them for your own data or your own use case. Okay, that is called as fine tuning. All right, guys. So then I don't want to waste this much time actually here. So what model approach we are using? There is also similar to decoder only model, but what model we uses here is encoder decoder model actually, right? So this is what the encoder decoder model, which is used by us in the ChatGPT kind of application. So whenever I try to pass the data, then data will be, guys, in the, yeah, guys, this Amar has already shared the feedback, Renuka ma'am. So you can refer to the chat box. Let me see if I am able to copy paste the same link here. No, guys, I am not able to copy paste the same link. So you can refer. Amar will keep on posting within 5 minutes. Okay, guys. Amar has posted again the feedback link. You can refer to that. Whosoever not got the feedback link, guys, you can refer to the chat box. Amar, my colleague, has pasted the link. You can use that link. All right, guys. So this is the sequence to sequence model, encoder decoder model is happening. We are passing our data, which is in the database. Now it is a document filtering happen. Then this entire sentences will be taken, broken down in the tokens, guys, and that will be taken here. And then there will be, you guys already know, the tokenization, then the encoding, word embedding, and then the position encoding, then the encoder decoder model. And then, guys, we'll try to generate our use case. What use case? Like machine level translation, machine summarization, and question answering. Because we can see here, so whatever the encoder only models were there, those are not used for this kind of a question answer chatbot, right? Just like the ChatGPT, they are only used for the sentiment analysis, name entity recognition, or classification, like emotion analysis, emotion detection. But whenever we are trying to generate this bot, right, chatbot like ChatGPT application, they are using this model, guys, sequence to sequence model, which is coming up with that encoder and decoder both model. So one is trying to encode the things, then it will try to decode the things, and same information which we have created here, the same information is passed on to both the things, and then it is trying to generate. And this kind of a BERT model or the LSTM model or the GRU model or T5 model. The T5 model was special model, guys, which are generated by the Google. So this kind of a model are taken care, are generated by using encoder decoder approaches, or VAE model, variational auto encoder decoder. This kind of a models are there, which are able to generate this kind of a sequence to sequence modeling. This model are used, and that is how, then once we have this encoder decoder model, then we can create a machine level translation, text summarization, or question answering chatbot like just the ChatGPT. All right, so I don't want to waste much more time. We have already discussed this architecture. Now, guys, what is the actually challenges with the pre-training? Now we have understood, if you want to do a pre-training from the scratch, then we have to use one of these approach, like encoder approach, decoder approach. I told you that if you want to start from the scratch, this model, you have to have a data in the gigabytes, petabytes, zettabytes, and then you have to train this kind of entire layers by layers, and then you have to understand that what will be the model size, data size, and accordingly you will require a limitation of the resources. Now, then what is the limitation you will also receive, and what kind of a calculation? I told you, right, how these parameters are getting generated. Now I will try to talk about this, that what are the challenges with pre-training, like. So pre-training challenges, guys, computation memory. Let's try to understand. So how much memory you will require for creating this kind of a parameters? Let's try to understand. One parameter, guys. Okay. So when I am saying, like you guys have seen, so when we built a artificial neural network or a convolution neural network, so at that time when we are taking only 3 layers of information, right? Yeah, feedback link is shared, guys. My colleague Amar will share it once again, okay? In the chat box. In the interval of 5 or 10 minutes, guys, we will keep on posting. Don't worry. So, guys, we have understood that. Yeah, guys, Amar has pasted once again. So, please refer from there. So, guys, we have understood that whenever we try to build an artificial neural network, and when I was just building the simple neural network, like it is having this kind of a input layer, then there were the two hidden layers. We're taking only hidden layer 1 and hidden layer 2, guys, and then we have a output layer where it consists of only one neuron. And this kind of architecture we created at that time, you guys saw that it was able to generate around kind of 1,000 parameters. So 1,000 kind of a parameter for this simple architecture, guys. Now when you are trying to train your model, large language model, let's try to have a calculation understanding that how it is trying to generate the model and how it is trying to take the computation memory. Okay, so what happens is, guys, one parameter take the 4 bytes. One parameter take the 4 bytes, and then when I'm trying to understand about the one parameter, and it is considered of 32-bit floating points, right? Floating points, floating point. So one parameter, one single parameter takes the 4 bytes of a memory, guys. 4 byte. Okay. Then try to understand if we are trying to train our model in billions. So try to understand billions means 4 into 10 e raised to 9 bytes, right? 10 e raised to 9 bytes. That means 4 GB of data. So 10 into 4 into 10 e raised to 9, right? 10 e raised to 9. So that kind of a data will come across. I'm giving a across calculation. So if you are taking 1 billion parameters, right? 1 billion parameters come to 4 GB. Now try to understand, these are just the model parameters, correct? So these are model parameters means apart from this, what are model parameter? Weights and biases actually. Because I this equation y equal to wx plus b, right? And you have understood that at that time, when I am trying to train this kind of a model, at that time, what is happening is, so we have a two architecture in the transformer, right? So we have a base LSTM model or kind of a GRU model or kind of a BERT model, which we have understood, right? And plus that, we have something called as artificial neural network. And this comprises of one encoder. Similarly, such decoder will be there. Now, what is happening is, guys, let's try to understand that whenever I'm trying to talk about this artificial neural network and LSTM neural network, they have their individual weights, because we have understood that when I'm trying to talk about the RNN cell also, in this RNN cell also, we have a neurons. It is trying to generate output, and this output is again given back here. And here we are passing our input, right? At that time, what is happening? There is a one weight here, and there is a one more weightages here. So weight one will be there, weight 2 will be there, right? So what is happening? Weight 1 and weight 2, such weights are there. Now these kind of a parameters are our model parameters actually. These are called as our model parameters. But apart from the model parameter, if you are trying to take the optimizers, we already know what are our optimizer, right? Gradient descent optimizer, which are trying to reduce my loss function, or Adam optimizer. That optimizer also taking, guys, that optimizers are also taking 8 byte of memory per parameter, 8 byte per parameter, 8 byte per parameter. My model parameters take the 4 byte per parameter. And then when we're trying to have a gradient descent kind of a things, so this two Adam optimizer taking 8 byte of parameter, then we have a gradients, means derivatives, which we are trying to calculate, right? Derivative of loss with respect to weights, and they are creating plus 4 parameters, plus 4 bytes of memory, 4 bytes of memory per parameter. Then we are trying to perform activation functions. We already have, let me write it in simple way. Something called as model parameters, which are nothing but my weights and biases. So which are taking my 4 bytes of a memory, 4 bytes of memory per parameter. Then I have then I have optimizers, like which are trying to reduce my loss. They are taking 8 bytes of memory per parameter. Okay. Then I have something called as my gradients. Gradients means my derivatives, which I am trying to calculate, that are taking plus additional 4 bytes of memory per parameter. Then I have something called as my activation function. Everyone know what is the activation function. So to activate or deactivate the cell to bring the non-lineation, they are taking plus 8 bytes of memory plus per every parameter. This way, guys, my model parameter, my optimizer parameter, my gradient descent calculation parameter, and my activation parameters. So these many parameters are getting added. If you try to take the example, guys, what will happen here? The 4 parameters, 4 byte of parameter plus, if you try to take the example 4 from my model, and this 8 plus 4, 12 plus 8, 20, extra 20 from my activation and my gradient and from my optimizer, means what is happening? 4 plus 20 means 24 per parameters. Now we try to understand, and this 4 plus 24, when I am trying to take that, it is trying to take this 1 billion 4 GB, right? 1 billion taking 4 GB at the 32 bit precision, right? So that time try to understand. So if I'm trying to take like at a 20 billion parameter, 10 billion parameters, what will happen here? So this 4 GB of memory is taken by this kind of a parameters, by this 1 billion parameters. They are trying to take the 4 GB memory plus this additional 20 parameters, which will be for 1 billion, which is trying to come to 80 GB memory. Correct? So this 20, remaining 20, because this 4 only creating 4 GB memory, this extra 20 will contribute, guys, for 1 billion parameter, 80 GB memory. So now try to understand how difficult it is to perform this computation. 80 GB of a memory for 1 billion parameters. Now try to understand, if you are trying to train your model on 10 billion, 30 billion, like ChatGPT trained on 30 billion parameter. Now you have to understand how many calculations it will take, right? So that is the problem, guys. Everyone cannot train the large language model from the scratch, right? So, and then what could be the solution for this one, guys? So we can perform something called as quantization. Quantization means, guys, it is trying to, whatever the 4 byte of memory we are taking or 8 byte of a memory for model, we trying to reduce that precision scale from floating point 32 to floating point 8. So that is called as quantization, guys. It is try to reduce the memory used for the model training and storing purpose. If we try to perform a quantization of a training, it will simply try to convert that 32 bit precision to 8 bit or 16 bit precision floating point. Okay, floating point 8 or floating point 16 from 32. And this way, guys, it will try to reduce the model parameter and the entire memory it is trying to utilize. So this is one more method. That is why if you have heard that why they are trying to focus more on the quantization technique, because of this only. So whatever the model parameters which were taking, which was costing around 80 GB of a memory, guys, by using this 32 bit floating point, we are using that, right? So they will try to convert them into 16 or 8 bit, and then they will try to convert the memory. So it will take a less memory of this. So that is called as quantization method. Then, guys, obviously you will require GPUs. Now what is happening here? Okay, I will try to repeat how we got 24 now. So let's try to understand, guys, simple way. One is called as model parameters, right? So whatever the neural networks, artificial neural network I am building, which consists of this kind of equation, right? Y equal to WX plus B. Okay. So this WX plus B, this kind of a parameters are there. So one parameters are there. One parameter takes the 4 bytes of a memory, 4 bytes memory per parameter. Now what is happening is such 4 parameters, 4 bytes of memory will be taken by the model parameter. Then there will be two such parameters will be there. So how much memory they will try to take? 8 bits, 8 bytes, right? 8 bytes. Link is not opening. So guys, I think other guys are able to open. Please try to refresh or something like that, Anu. So you'll be able to open it, okay? So guys, this one parameter now, model parameter, is creating 4 byte. So then there will be 2 additional parameters from the optimizer side. So 2 parameter will be 8. Then there will be gradients, means the derivatives which we are trying to calculate, which will creating again 4 plus 4 bytes extra. And then there will be activation functions. Activation function will create a 8 byte extra. So this way, guys, if you try to take this 8 for 4, 12, 12 plus 8, 20. And then this remaining my model parameter 1, that becomes 24. Now understood what is 20 extra coming from? This is coming from the optimizer, gradients, and activation function. 2 optimizers are taken, so that's why 8 bit. Then gradient 4 bytes and one parameter for an activation function, again 2 parameter. So that's why 8 byte per parameter, right? So this way 20 extra bytes will be coming along with this my normal 4 byte, 1 perimeter, right? And such 1 billion will be 4 GB. So if I try to take this kind of entire thing, it will come to 80 GB, guys. No, guys, this will not remain constant. So that's why I'm saying this for 1 billion parameter only. See here. Okay. Now you are asking that whether these bytes will remain. Yes. These bytes will remain same, guys. So if you are trying to take 2 optimizer, it will occupy 8 byte. If you are trying to take the gradients calculation, it will taking 4 byte, activation function 8 byte. This will remain same, but depending on the billions of parameter you are trying to calculate, it will try to occupy more and less data. Okay, I guess I am able to make you understand what is happening here, right? And that is why, guys, they are using quantization technique. Quantization means whatever the floating point data is there, they are trying to convert that data into the lower kind of a scale, lower scale, like from 32-bit, they are converting to the 8-bit or 16-bit. And this way, try to save the memory, guys. Quantization technique. All right. Then what is the other method, guys? Other method is, let's imagine here. Now, you will say that the both methods will be same. No, this is not as happening. Let's try to understand what is called as. Now, let's imagine you are trying to deploy multiple GPUs to train your model. Okay, multiple GPUs to train your model. Now, what is happening? Let's imagine you are loading the data. Now, what is going to happen is, let's try to understand very, very carefully how I am trying to train my model. There are 2 approaches actually, and both the approaches I am using multiple GPUs. Now, you can see here, whatever the boxes are there, that boxes are GPU 1 to 4. Okay, so GPU 1 to 4 means GPU 0, 1, 2, 3. 4 GPUs I am taking, and then I am passing my data and training my large language model. Entire large language models are sitting in one kind of a GPU. I am taking 4 GPUs. Now, and the second approach which I am talking about, fully shared data parallelly. So here what is happening is, guys, now I am taking 4 GPUs, but I am trying to split my entire LLM models. Now here, whatever the 4 GPUs you are seeing, here I am trying to split my models. I am not taking my entire model. That is the difference. Okay. So let's try to understand this one. What is happening actually here? When I am trying to take this is the data loader. It is passing the data. Now what is happening is, this is GPU number 1. This is GPU number 2, GPU number 3, GPU number 4. So GPU 0 to 3. So 4 GPUs in total I am taking and trying to train my data. Now what is happening is, guys, when I am trying to train my data, I am taking my entire whole model here. Whole model, whole LLM model, whole model. Then I am trying to take 4 GPUs. Then I am trying to train. Now what is happening in the train, guys? It will do a forward propagation. It will do a backward propagation, and it will try to calculate the derivatives, which is called as gradients. Now it will try to perform this all different operation on the different GPUs, and then it will try to sync the gradient. Sync the gradient means whatever the derivative is happening here, it will try to perform the derivative synchronization, and then it will try to calculate the final weightages. Final weights and biases will be calculated, and then I will try to update your model. Okay, so that is the difference. That means the same large language model is getting trained on the different models, and at that time we'll try to perform both the operation, forward, backward propagation, and we calculating our weightages, right? And then in the end we trying to combine those weightages. Now, other than that, distributed data parallelly. Okay, this is called as distributed data parallelly. So rather than that, we are trying to do a fully shared data model, which is always advisable actually, rather than providing the different GPUs for the different language model. I'm trying to split my large language model. See here, large language model is broken and kept in the parts, guys. So what is happening is, rather than passing my entire data here, I'm trying to take one chunk of a data, then I'm passing here. Then I'm trying to take the second chunk of a data, I'm passing here. Third chunk of a data, then I'm passing my model, and fourth chunk of data. Means my entire model data is split into 4 parts. This is my first part, this is second, this is third. First time this part is going, second part is going second time, third part of the chunk of the data is going, and then fourth part of the data is going, and going to the separate large language model. Then when this model will try to understand by using forward and backward propagation, they will try to update the weightages, guys. In the end, I'll try to combine their weightages and try to update the models together. Okay, so what is happening here? I'm splitting my entire data into the small chunks, and then I'm training my different large language models. So now, previously what was happening, I'm trying to take the same data, but I'm trying to train the different model. So that is the difference, guys. Okay, so here the models are splitted, data is also splitted, and then I'm passing. So this is called as fully shared data. Now coming back to the question that whenever trying to train your model, guys. Okay, so I know it is going very technical, guys, but it is how the entire architecture look like. You should be able to understand how it is trying to do the performance, and how it is trying to perform an entire calculation about the parameters, about the training time, about the entire configuration. Okay, so let's try to understand. This is also very interesting try to understand. So how you should try to perform a optimal computation configuration for the large language model. This is very important, guys, because when in real time when you guys try to build this kind of architecture, obviously you have to understand this constraint. What is the constraint? You have to understand that how many number of tokens you have to take. Okay, how the constraint calculation will be done, or how to perform a optimal configuration, guys. First you have to understand what are my configuration constraint here. Let's try to understand choice of the training data size, then choice of the parameters, guys. So here we have seen that our ChatGPT model, they are trained on the 30 billion parameters. You seen only 1 billion parameters when you try to add with this kind of a 24 bytes of a memory it is taking, it is coming up to 80 GB. Now let's imagine if you're trying to take the 30 GB multiply by 3 means 240 GB or plus or 320 GB, okay, right? So that kind of a 240, right? So that kind of a calculation will happen, sir. Then you have to understand the model parameter. You have to understand the number of tokens you are passing. And then guys, you have to also understand about the budget and constraint of the GPUs. Because every GPU has a limitation, guys, because you have to pay around $2 or $1.5 per hour GPU cost for using the GPUs, right? So be looking at all the budgets and constraint, this constraint, guys, you have to build your model, right? Whatever the model you are trying to build. Now, what is interesting, guys, try to understand that the matrix cost computation calculation is done by this kind of a parameter, which is called as petaflop, actually, petaflop per day. Let's try to understand what is this peta. Peta means, guys, it is a floating point operations, floating point operation, okay? Peta means floating point operation. Floating point operation performed at a rate of 1 petaflop per second, guys. 1 petaflops. Flops means floating point operation. 1 peta floating point operation at a per 1 second for 1 day. For 1 second for 1 day, guys. Okay. So let's try to understand. If you're trying to perform this kind of a calculation, guys, 1 petaflop operation. Okay. So it requires this kind of a quadratic floating point operation, guys, which is this one. Let me tell you here. 10E115. Or you can say 1. This is represented by 1 quadrillion. 1 quadrillion, guys. Trillion. 1 quadrillion. Quadrillion means trillion multiplied by 4 times. Quadrillion. Okay, quadrillion. So this 1 petaflop is floating point operation. 1 peta floating point operation per second. Okay, it is considered as a quadra floating points operation per second. Quadrillion, actually. Quadrillion operations are happening. And if you try to take this 1 petabyte per second minus the day required, let's say you are taking this kind of a NVIDIA V100 chip running for all this operation 24 hours, right? So if you're trying to take this kind of a things, which is run which takes the 24 hour by 24 hours, it is running this kind of NVIDIA chip, guys. To perform this kind of a things, it will take 8 days for 1 petaflops, okay? So 1 petaflops, okay? Flop means floating point operation. Peta is, guys, GB, zettabytes, petabyte, okay? That kind of a petabyte I'm talking about. 1 petabyte comes to quadratic trillion. Quadratic trillion operations. Quadratic trillion, okay? Quadratic trillion operations. So this operation takes around 8 days, guys. 8 days if you are trying to run your GPU 24 hours. So let's imagine 1 petaflop operations requires 1 petaflop operation requires per second a day requires 8 NVIDIA chips running for 24 hours. 8 chips required. Sorry, I was talking about 8 days. Now, not 8 days, actually, it requires 8 chips running for the 24 hours. Let's imagine, okay? So if you're trying to create this kind of a things, 1 petabytes only requires your 8 chips running for the entire 1 day. 8 chips running for 1 day. So guys, to create this kind of things, it will require this kind of a 1 petaflop per second requires a 2 days, okay? Day requires a 2 now. So 2 days for that, this kind of a running, this kind of 8 NVIDIA chips running for the 24 hours, such 2 days will be required. So if you're trying to create a parameter like this one, that's why they are trying to say here, if you are trying to create a model, which is like ChatGPT 3 model, which contains the 175 billion parameter model, right? It will require 3,700 petaflops per second days. Means how many? Only 1 petaflop seconds. 1 petaflop operation per second will require 8 GPUs. You can say simply 8 GPUs for the 2 days, which were running 24/7, 24 hours, right? So for 1 petabyte only, 1 petabyte of flop operation. Now imagine for 1 petabyte of flop operation, we require 8 GPUs running for the 24 hours for the 2 days. Now whatever the GPT-3 model it has created, which comes to 175 billion parameters, guys, it requires such 3700 petabyte flop operations per second flop operations. So means imagine how many days it will require, guys. How many days it will require to perform this operation, right? So that is why, guys, it is not feasible to train all the models at once. Right? I know it is going very like I'm going in detail, like how to perform even cost optimization, cost calculation. But it is always interesting, guys, to understand that if you want to build your own model, so what kind of a cost you're going to require, or what kind of a petabytes of flop operation. Flop operation means floating point operations, right? Per second, 40 point operations per second, 1 petabyte of operations per second. Such 2 days of 24 hours, 8 GPUs, right? So this is what you require. And if you want to create this kind of a OpenAI kind of a GPT model, so it will require around 3,700 petaflops operation per second for the day. So then you can train this model, right? Now, guys, okay, in the end, what is the conclusion we are trying to take this? So what they're saying is they have created one research. So two research they have conducted in 2022, and the paper was published under training compute and optimize the large language model. Okay, so this was the study done, and they have studied large language model, guys, various smaller for various data and sizes, and what they found out, that paper was called as Chichila paper. Okay, Chichila paper. This is a famous, and they what the conclusion they have received. Okay, what conclusion they have received, that it is one important takeaway they have done from after studying this large language model, that whatever the models are there, when you are trying to perform an optimal number of training token, guys, it should be the 20 times the number of parameters. 20 times the number of parameters. So if you are trying to take your parameters, 1 billion parameters, 1 billion into 20. That many tokens means 20 billion tokens you will require to perform a optimal training for this purpose, right? So what they're trying to say is here is, in short, what they're saying is, even if you try to create a small model, guys, and that if that small model are domain specific, they will try to outperform the larger model. This is what they are saying here. Okay. So that is why you have to perform a domain specific adoption. Like if you're trying to create a medical kind of a chatbot, try to train them on the medical data set. If you're trying to create a legal kind of a chatbot, try to train them on the medical legal terms. Okay, that is what they are saying. Okay, now I think I know it is very, very tough calculation we have spoken about. So guys, we'll try to continue this discussion about how you can evaluate your large language model. What are the scores? There's the rogue score and value scores, how to calculate them one, and then how to perform this entire LORA, low rank adoption, and this human feedback. We'll try to understand. Yes, very simple concepts are there, and then we'll try to understand this entire RAG concept as well. So tomorrow I will continue with this one. I know it is already the time, guys. So we'll try to understand how to evaluate your model, how to perform this efficient fine tuning with the soft prompts and LORA prompts, and then we'll try to understand this human feedback model, very, very simple model, and proximal policy. And then, guys, we'll try to build the model tomorrow. We'll start building the models. Yeah, Dharam sir, thank you very much. I know, guys, it's the time. We'll try to conclude here. Tomorrow, we'll try to go into the details for this human feedback reinforcement learning and the proximal quality optimization, guys. All right. And then we'll try to understand the last concept, which is the RAG concept, 5 minutes. And then we'll build a model, guys. Along with that, we'll also try to understand how we should use the chain of thoughts, what is the program-aided language model. So how it can be done, how you want to customize your model. At that time, why RAG means there's nothing but simply try to understand. Retrieval augment generation means whatever the transformer model you have, you will try to connect that model to the external databases. Some kind of external databases where you can input your customized data. So that architecture I will try to discuss here. What is the RAG? This is very, very important concept, guys, because whatever the applications are created here nowadays using the large language model, they are using the RAG methodology only. Okay. So RAG methodology is retrieval augmented generation, guys, and that is nothing but a simple database they are trying to expose here. So this database is an external database which did not have the data which is on which the models are trained. So they are trying to take the external database where the model is not aware of that, and they are trying to combine your model with the external database. Then they are trying to do a prediction, guys. Right? That is the simple concept. We'll try to understand this one. We'll try to understand how the chain of thoughts are making example here. And what do you mean by program-aided language model? Means what is happening is, so whenever you are trying to perform this kind of a code creation, at that time, guys, how they're trying to write a query outside, and they are using some kind of a scripting languages and try to bring that code here. So whenever you ask the ChatGPT that how can I write a code for the machine learning language, right? At that time, internally, how it is trying to perform the coding, that concept is called as program aided language modeling. Okay. So we'll try to understand this concept. Very, very important concepts are there, guys. And then we'll try to understand once these are very, very critical example. Why I'm trying to give you this insight, because you should be thoroughly available, like how, what kind of a cost you will require, what kind of a parameters are getting generated, how much parameters are there, what kind of an entire training process happening, right? So then you should be able to understand in and out, like you can create an entire design, guys. All right, guys, I know I have spoken a lot today. So hope you found out this very interesting, how the entire insights are there internally, how the things are happening. And we try to end up our discussion today about the training with this concept, RAG concept, chain of thoughts concept, and the supervised fine-tuning, proximal policy optimization concept. And then, guys, we'll try to build the application starting from tomorrow. Yeah, guys, Ayesha ma'am and Kalpana ma'am, thank you very much. Dharam sir, thank you for your invoices. Sorry for your kind words, guys. So thank you very much, sir. So guys, we'll try to conclude our session. I know it is very heavy thing which we are trying to digest out here. So please let me know if you have any questions or anything, any suggestions, any thoughts, other thoughts rather than this. And we'll try to continue this discussion and try to start building the application from tomorrow onwards. One more thing, guys, don't forget from tomorrow onwards, I am going to discuss the LangChain application as well. So LangChain is the framework which is popularly used now to build the large language model, just like the ChatGPT kind of model. So I will try to discuss. I'll try to discuss Hugging Face as well. So if possible, and I know this 5 days is very short time, guys. Actually, if you want to understand this entire generative AI, it requires minimum 3 to 4 weeks, because now you are able to understand, right, why I'm saying this kind of things, right? So because look at the flow of this petabyte of flop calculation and everything, right? All right, guys. So thank you very much. Any other questions or anything else? Otherwise, I will wind up the session then. Yeah, okay. Thank you, Deepak. Okay. Guys, whosoever not marked the attendance, Amar has shared once again this attendance link. You can mark your attendance for the day 3. And if no further questions, and so then, guys, we can wind up our session. Thank you very much then, and see you tomorrow with the practical example and remaining part of the training. Yeah, guys, in 1 minute, I'll wind up the session. Please go through the feedback link and attendance link and try to mark your attendance and feedback accordingly. We'll wind up the session. Yeah, Deepak, thank you very much. Thank you, guys. I'll see you tomorrow then. All right. So, Amar, please go ahead. You can close the session. Thank you.
Yeah, sure. Thank you.